Now this is a question to ask if you can work out the radius and of an atom or an ion, and you're given a bunch of radiuses and asked to match them up. So the first thing is to get some idea of where these elements are on the periodic table. We have gallium and selenium in the same period, and we have sulfur immediately above selenium and its group. Now, just looking at those three elements by themselves, you should be aware, for instance, that gallium is going to be bigger than selenium. It's got, as we go across, we get more protons in the same energy level, and so selenium would expect them to have same electron shielding, but greater electrostatic attraction due to greater effective nuclear charge. And then if we look at sulfur, we see that it's actually further up in the group, so we'd expect sulfur to have a smaller radius still. So we have a basic idea of how the atoms will be within that, or the elements would be within that group of three, without considering the ions. Now we have to consider whether, in the case of selenium 2-, obviously having the extra 2 electrons is going to increase electron-electron repulsion, and we'd expect this to be bigger than selenium. Do we expect it to be bigger than gallium though? Now, electron-electron repulsion is quite significant, so in this case I'd expect selenium to be bigger than gallium, so I'd put that there as being bigger. Gallium bigger than selenium, bigger than sulfur. Now we have to consider gallium 3+, and obviously we've lost 3 electrons, and if we consider the electron configuration, these electrons are being lost from the 4s and 4p orbitals, so in fact we're actually dropping an energy level, so gallium 3+ is in the same energy level as sulfur, and we have more protons, a lot more protons, so we'd expect it to be much more strongly held. This is the one that is likely to be the most awkward one to get. Which one is bigger between these two? And once you've worked out, and it's taking the time to consider the electron configuration in these awkward cases, because that will give you better insight. And as soon as you realize they're in the same energy level, so therefore electron shielding is going to be the same, and when you realize of course that gallium is going to have less electron repulsion with using those electrons as well, and also, more importantly, more protons, greater electrostatic attraction, would expect gallium 3+ to have the smaller radius out of there, so the last one would be gallium 3+. So that's your sequence, and now you've just got to explain it. Now this question could take a little while to actually explain. I mean, you could start by talking about just the ions, how gallium 3+, having lost 3 electrons, means it's really lost an electron energy level, and there's going to be less electron repulsion going on here, and because those electrons are closer to the nucleus, they're going to be more tightly held, so we're going to expect gallium 3+ to have a smaller radius. And you could also talk about selenium 2+, how in gaining 2 electrons, it's got everything else is the same protons, same electron shielding, but with the extra repulsion means that the outer radius is going to be much bigger. Now that's fine with the ions, but how about in considering these? Now I've just done these in order of how we've decided them. Why is gallium 3+ going to be smaller than sulfur? Well, in this case you need to talk about how the fact that they're in the same energy level, and then you need to be talking about the number of protons there, and that means the nuclear charge being so much greater is going to be greater than sulfur. So that means that sulfur is going to have less protons than gallium 3+, Gallium 3 plus is going to have much greater electrostatic attraction. Electrons will be tightly held at smaller radius. So that's that one. That's what we're really talking about in that one. Sulfur is smaller than selenium. This is more your standard one where sulfur is an energy level closer in. There's less electron shielding. Even though selenium has more protons, the fact that sulfur has less electron shielding and is physically closer means greater electrostatic attraction is going to result in sulfur having a smaller radius. Why is selenium smaller than gallium? Well, gallium has less protons. They're both in the same energy level, and as we go along we get more protons being added, we get greater electrostatic attraction, therefore we expect selenium to have a smaller radius than gallium. And finally, why does gallium have a smaller radius than selenium 2 plus? Well, they're both in the same energy level. Even though and selenium has, even though it has more protons, the electron-electron repulsion is a significant factor in making that radius bigger. This would also be a tricky one to get, but you have to realise electron repulsion is a big factor. Okay, so that's that question answered.